Well, good morning. Welcome to day 2 of Tech Field Day San Jose, Tech Field Day 4. We kick it off with an old friend of mine. Ash and I have worked together 12 years ago, 11 years ago, something like that.
That's right.
At Storage Networks, the original storage service provider. And since then, we've kind of been talking to each other about what's going on and what we're working on. And so I'm really glad that he can come and share that with you guys too, because well, last night we were talking about startups and being in the data path and the peril of that. He's found a loophole. So let's see what his loophole is. You ready?
Sounds good.
All right, take it away.
Thank you, folks. Good morning. Sorry to have got you up. Most of you are probably off the time zone like me, but some are probably in it's still the early morning phase here. I had a chance to meet a few of you. Want to introduce myself for the others. My name is Ash. I'm the president and CEO of Actifio. Also joining me is Steve Blumenau. Where is he? Steve runs our marketing here. How many of you know about Actifio? Okay. There's a reason for that. This is the very first time we've actually flown out of Boston and actually come and presented Actifio to an audience outside of an hour and a half of Boston. And it's a very clear reason for why that was. We were very, very focused on making sure this company could be built out to the point where we had about 24 customers within the Boston area. And the goal was if we can't get 24 customers around Boston, maybe we should really shut this company down and move on. And so I think we finally accomplished that. We took the flight, talked to Stephen, and saw this as a wonderful opportunity to come and talk to you guys and get your feedback. So taking this opportunity of finding some unique set of people here, I wanted to go through a couple of big things. One, give you a complete opportunity to give me feedback on this company. So I'll start off with the background of how we got to what we do, give you an idea about the technology and what it takes to build what we do, go through a quick demo of the product, the real product actually as it's working here. But then to make the entire picture complete for you, since you really haven't heard about the company, exactly how people use it, who are the various users who use it today, how they use it, how it's applied in the market today. This is a pretty broad project. Prior to this one, I was actually a VC. Spent about 7 to 9 months researching on an investment thesis, and I loved this project good enough to go jump in and run it. And this is really a large space for us to go back and look at. So bear with me as I start off with this big picture, bring it down to what we do, then apply it to how people actually use it, and then show you a demo of this thing. Fair enough? So you're getting the entire business plan for the very first time outside of the Boston area. And I want to thank you guys for that. So let me start off with the background of this whole thing. Trying to run a business app. Most of you guys are very familiar with trying to get an application up and running. Fairly simple process. Bring in a virtual server, a physical server, lash it together with some storage, data starts to flow. So far, so good. The minute the data hits the disk, the very first thing everybody starts off with is saying, I better back it up. So I make copies of this data on a nightly basis within my 2 a.m. to 8 a.m. window, pull it over to either tape or disk, and make sure I get it out to a remote site for DR. And that's good enough for 24 hours of protection. For those who want RPO smaller than that, applications that require quicker restores than 24 hours, we invented Snapshot to say every 4 hours, every 3 hours, keep a copy of the data so that I can restore it just in case I need data between the single day that I've been backing up. And then businesses became even more highly available. People started worrying about sites, disasters on a site. So you go back and replicate the data. Whether synchronously, asynchronously, you come back and try to make sure there's another almost near real-time or real-time copy of the data. And then there's more copies made as people want to share information, use it for compliance, use it for analysis, use it for test and dev. And it's pretty much, there's a good slew of reasons why copies of data are made for various kinds of reasons. And then came along VMware, completely disaggregated the relationship between a server and storage by having this virtual guest OS, virtual servers. And there was another piece of software deployed to try to optimize how you back up for VMware. So we looked at this whole picture and said, let's take a look at what exactly is going on behind this one. This was November 2008. We're starting to look at this whole space and trying to understand what exactly was behind this. So if I look back at the technology, you had a bunch of application data blocks being written, overwritten, changing all the time. And every so often, an application comes along called backup, takes the data, creates it into a stream that's appropriate for tapes, and puts it out on tape. And then backup being so stupid that it was, people figured out, hey, there's a better way to optimize how you do restore and get the cost optimization by using deduplication. So you fix the back end of this process by having a deduplication stuff. Then, of course, you have the snapshot, making another copy every 4 hours, every 3 hours. You have the replication, making a copy, again, maybe real time or near real time. And this process pretty much goes on for days, weeks, months, and years. If we dig a little deeper into what exactly is going on across these 3 apps, there's something interesting we found. Number one, you notice is that every one of these apps starts out making a copy of the data. 2, every one of these guys retains it for a certain amount of time. And lastly, they're all vertically integrated applications, and so they all use their own stores to store their copy of the data. So there's this common process that you see across the board of copying, retaining, storing, moving, and eventually restoring. And that becomes the fundamental premise for all the data management. If I look back at data management and we look at all these apps that are trying to manage various parts of the life cycle, there's a fundamental set of primitives we started noticing that becomes the foundation for data management. You copy the part of the data you want to manage, you store it, you move it if required, and then you restore it. So we looked at this and said, what exactly has happened as a result of all this stuff from a user's perspective? And it looks pretty bad. It's a very simple story. There's not a single argument we hear when you go to an IT organization and say, surely you're spending a lot more, both in terms of money and time, on making and managing copies of data than the original data itself. I used to run HP storage division for a while, and I noticed that there was a ton of storage, mid-range storage that was going into managing copies of stuff, especially when you started moving a lot of backups to disk. But bottom line, people spend 3 to 5x more on making and managing copies. There's about 13 to 120 copies of data, depending on how big an organization there is. And this is across all kinds of copies. Any thoughts, comments on why these are not true?
Is it multiple copies for backup, or is it just users sharing files where I have this file, I'm going to email it over here, and then they have that file?
No, this is all secondary data.
Okay.
So we're leaving the primary data completely separate. We're assuming somebody is going to take care of that part. Our focus is completely on the fact that, and it's no different than what you've done. You got this digital camera around, you buy an $80 SD card, and pretty soon you spend $500 to $1,000 on all kinds of data stores for either 5 PCs that you put it on, upload it on Flickr and Picasa, and get 2 online backups. Pretty quickly you got, it's no different than a personal life. And this happens in enterprise purely for things like backing up, for quick restores, for test and dev copies. So these are real copies of data.
So how does copy on write play into this with the data set?
That's a good point, and that's one of the techniques for snapshot itself, right? It's just one of those techniques to make copies of data more efficiently, but that's more of a technology. But I think we're looking at the whole space saying, okay, use copy and write, but that's for this guy, but you don't use it for backup. This other guy is a whole different beast. He has ETL tools that pull out data because they do data warehousing kind of stuff. So what you just talked about is one technique here. What you talked about, what backup guys talk about is another technique here. There's VMware guys who do a whole other stuff, pulling it out from VMware, and so on and so forth. So it's fundamental applications. It's the fact that parts of data management are run by different applications that go through the same 4 primitives. They all copy it independently. They all store it independently. They all move it and process it. and then they all restore it independently.
Okay.
Any other? So this was kind of the foundation of where we started looking, digging deeper, and coming back and saying, okay, now let's see if we can find a way to optimize this whole process. What if we took those vertical applications and started out with the fundamental premise? Let's say instead of each of you guys having a copy of this data, there was one copy. There was a continuum of all the copies over time. That is just this one single source for all that stuff. Two, because you have a single copy, you can now completely optimize on capacity and movement from a network bandwidth perspective on that single copy, as opposed to, for instance, this guy optimizing the back end of this one, but nobody really taking care of this one. So literally applying, I hate to use this cliche, kind of the dedupe, compress, optimize stuff across all the copies as opposed to one. And then you come back and say, everyone buys their own storage. I mean, innovation storage consistently has become packaged in a sheet metal. It comes with disks. You want compression, you got a box for compression. You got deduplication, you got a box for deduplication. And if you come back and say, well, there was a time, I built the very first disk arrays way back in 93, 94, at what is now LSI. And we built it for one single reason, for reliable storage up and down. And let's come back and say, I just want to use reliable storage to keep these copies. I don't want to depend on having to buy vendor X, vendor Y, or cloud storage, or sheet metal storage. Just give me a choice of whatever storage I want to keep stuff on. And then come back and leverage virtualization technology to say, let me give you a window and the format of the storage you need for each of these applications precisely as you want it, but there's a single base. Very, very similar to what you would see for VMware virtualization or server virtualization. Instead of having compute, what you have is a store of data that you can create views out of for each of these things. Now this becomes kind of the most optimized underlying data store technique for copy management. Now you can apply this to primary stuff too, but we're not talking about primary. And that was good enough, except what we found was this was the tail. The real dog was the fact that you have these applications over and over again that are pulling out data, they're impacting servers, they're impacting storage. In fact, yesterday I was talking to a couple of guys who talk about, you probably see this, when you provision bandwidths and storage for certain I/O applications, you leave a bunch of room for the backup guy, the antivirus guy, all the copies that are coming out. They're all taxing the resources, pulling it out of there because of these guys. And so what we did was we came back and said, all of these guys are still doing the same primitives. They are doing copy, store, move, restore. Why don't we build a single engine that provides these primitives as a foundation, and then you can apply a single copy that is copied in and use some techniques to come back and manage it across the life cycle. So this is almost the back-end foundation, but this is the operational practice, the virtualizing how you go back and use that data. And it'll come back to how it's actually put together. But it becomes a very simple concept to come back and say, I use one copy of data now, and then I reuse it for various things. But the data itself is now self-describing enough to say, I'm supposed to live in a certain format for a certain amount of time. I'm supposed to be in 4 locations. But I think you guys heard about CDMI, object storage yesterday at NetApp. But this starts to do the foundation. The foundation of real data management begins with an object description that is kind of self-contained. And I'll talk a lot more about the technology underneath. But you're really coming back to saying, let me capture as efficiently as possible. Let me store it as efficiently as possible. Let me move it efficiently, and then restore it as you need it, as opposed to having each of these guys do on their own. Does this make sense? Now, many of you know data protection, disaster recovery, business continuity. For the last 10 years, every survey comes back and says they are the top business critical IT initiatives everybody wants to deploy on. They also stand as the top 3 initiatives among the most hated IT initiatives. Nobody wants to do those too. So we wanted to apply some paradigm that made it dead simple. Now this part is good enough from a technology perspective. Infrastructure-wise, okay, we've got a handle. Now how do you get to the point where it is dead simple, really, really simple to go back and do those business critical initiatives? And so from a packaging perspective, we just drove home from the company product perspective, in fact, down to, we were all Windows geeks for a long time. We switched to Apple as the primary platform for across the company to drive home the theme of simplicity across the board, and you'll see the product. And the simplicity is in many different ways across this one. There's the simplicity of how you keep data, but more importantly, there's virtualization applied in many, many different ways. There's virtualization applied to the storage side, but most importantly, from a usability perspective, everything starts off with a service level agreement. It's a SLA, a service catalog that allows you to classify all applications into whatever, enterprise critical, enterprise support, or gold, platinum, whatever forms you want. That's number one. Two, there's only three themes that we deal with when we are allowing people to manage data. What applications you want to manage, what is the SLA you want to apply to those applications, and finally, what kind of virtual resources. And no, there's no mention of LUN anywhere in this entire system. In fact, the company has about 46 to 50 people now. There's only one non-storage guy in the company, and he's the UI guy. I think he got the job, and he said, "You guys talk about a LUN. What is a LUN?" I said, "You're hired," because we want that whole notion of being completely ignorant of this LUN business. The rest of the team comes from EMC, Data Domain, Quantum, HP, pretty senior folks. People like Steve, who used to run sales at Iron Mountain, were the CTO office at EMC, ran their own companies. So it's a fairly senior team. And we drove home. It was very tough for us, for geeks who've been building storage systems to come back and put together something that is completely hiding the complexity of storage, but for a very specific purpose, which is secondary data. And that's kind of the basis of Actifio. And if you had to summarize what that really means, is if you took this copy, store, move, and restore process, you have a different paradigm, which is based on the fact that we want to decouple the management of data from the underlying infrastructure. No more do we want to say, oh, I want compression, I need to buy the compression box. In fact, if you want to go back and virtualize data centers, leverage cloud stuff, you cannot have sheet metal be a part of the infrastructure. You have to have self-describing data. You have to have something that basically says, I really don't care where infrastructure is. I want the ability to go back and manage data. And this applies best to this side. It's not terribly great on the primary storage side. And I can go through many reasons why. Number one, that's the fundamental paradigm. We decouple how you manage data from underlying storage. And then we take that foundation unified data there and apply the most optimized capacity management and network management throughout the process. And then we use the virtual data pipeline to reuse that copy for each of those individual operations. Now that said, we were pragmatic enough. We've been building companies for the last 15 years. We're pragmatic enough to know that we can't walk into a shop and say, I'm glad you love all this stuff, but let me come back and replace this with this entire stuff. So it was very important that everything we built here, and this is where I'll talk about the product and the solutions and the packaging, completely coexist with what's out here. In fact, most of the sales process is identifying which of these initiatives you're actually undertaking right now. And if the guy says, yeah, I got replication, I got snapshot, I got backup, everything taken care of, the simple question is there any place you're making a copy of data? And if you are, we'll show you the best way to do it. Now, it turns out, as part of doing one of those copies, we do everything else, but it's not because we're trying to integrate it. It is just that it's the nature of how the entire copy management is being taken care of. So it is important to come back and demonstrate the ability that if you could bring this in, and I'll show you how this actually works and how it's implemented. If you could bring it in here into an environment that already has somebody doing replication, snapshot, backup, and we are inserted into the network, or we insert into the infrastructure, none of those existing operation processes have to change. None of the infrastructure needs to change. We come in and we go out, and there's absolutely no disruption to the existing environment. Any questions? Is this all right? Not yet. So now this is time to get into the nuts and bolts of this one. And this is where I'm sure you guys love the story, the technical part. There is really a 4-layer architecture. At the bottom, we have a storage virtualization engine. When the cameras turn off, I'll tell you something that's under NDA, which makes it really important on why we're able to virtualize and get out of the business of being completely independent of the vendor and the storage, or even if you want to choose a cloud storage, it doesn't matter for us. It's just a store. But then there's a virtual data pipeline. This is the entire data management engine that optimizes how you do all those data management primitives. But in order for that engine to work, the driver here is the SLA workflow. If you are running applications, if you're trying to do your business apps, the ability to define what is the data management SLA for this app, it comes from here. And then you have the actual applications itself. The ability to come back and say, I do data protection. I need an app that makes sure that every 24 hours I have a window for me to get my data back. That's app 1. I need something that is on the disaster recovery side. That's app 2. It's actually the same engine. It's the same common data. But you're changing the paradigm of not having to have a siloed, vertically integrated app, as opposed to building an engine for all copy management and using different applications to figure out what operational behavior you want to get out of this thing. Getting even more detailed one, this is where the complexity is. There's about 32, 33 folks on the engineering side. A majority of them focus on this file system. And it's been about 16 months now since we've got the development going. What this guy's done is a remarkable file system that does a couple of things. It does the virtualization of those core primitives. First is to make sure you optimize how you copy. And when you see the demo, you'll see this whole process of saying, okay, let me see the smallest RPO, and that becomes a foundation for everybody else. If the smallest RPO is real time, of course, now you've got all the data. If the smallest RPO is 4 hours of my snapshot, it starts with that, and that is reused for other things. There's a very efficient way of copying it, and I can go through how non-intrusive it is to actually get the data out, and yet how it has no effect on the servers or storage. We're completely independent of, and in fact, there's one installation where we have a system Z connected to this. There's a mainframe connected to the environment. We don't even do anything with it. We pull it out. Once the data comes here, this is the object. I think there was a mention of CDMI yesterday. If you want to get data to be portable enough to be managed, it has to be self-describing. So we take the original data from the application, we combine it with the metadata, which says, what is the application that actually created this data? So because recovery is all about application formats. And then we have the SLA that describes what needs to happen to this data throughout its life cycle. So this little object that combines this data, metadata, and the SLA becomes the foundation for the file system. And after that, it starts, first thing it decides is which location does this object need to reside, and maybe it's actually a copy of it on the other side. What format does it need to reside? Sometimes if you want instant recovery for 4 hours, maybe it resides in the native application format. If you want to retain it for a longer time, it retains in a deduplicated format. If you want it on the remote side, it remains in a globally deduplicated format and compressed format and encrypted throughout the process. But that whole definition is now inside the object itself. So you now get to the point where you're not in the mode of saying, in the classic storage mode, which is, I'm a compression box, and all I do is compression. I'm a hammer. Everything coming in is a nail. I don't care what it is. Now you've got the paradigm shifted to say, I know exactly what needs to happen. I need a compression service in the cloud. I need a compression service or deduplication service somewhere else. You've changed the model more top-down as opposed to an infrastructure up. And that became the foundation for how you copy, how you store, and how you move the data. The most important part is the restore. And this is back to, again, another key piece of technology that will come back to once the cameras go off, is the ability to come back and provide an instant restore. I mean, if you know backups, restore for backup is you pick up a file, and then the backup application pulls it out and says, okay, where do you want me to put it? I put it there, and obviously a lot of this process depends on how much data you're recovering. The restore process is remarkable. We do an instant restore of any data available in any format that you want, and it is literally an instant. So you get to the point where you have a zero backup window. The question of backup window is gone. If you noticed, we fixed the dog, which is backup. The backup window is not about tape, not about disk. It's about backup. Now that said, we don't go off and tell people stop backing up because we say that's one of the options. You have instant restores, just like you would do with things like Snapshot. At the same time, you have optimized capacity and optimized network throughout the process. And the sorry, go ahead.
Can you back up, or can you restore to other devices?
Absolutely.
Okay.
Absolutely. You can restore to from virtual machines to physical machines, physical to virtual, from one array to another, from cloud back into the array, or from array onto the cloud. You just completely decouple those things that we've been stuck with from the edges for so long on data management. I mean, it's always been about, and this is the key here. I know exactly, so when I deduplicate something and compress it, there's a set of unique data. Parts of it might be actually shared by 5 different apps. They may be the exact same data, but when we recreate it, we know exactly how to recreate that's the part of the file system say.
From the metadata.
From the data and the metadata. So that you have the data blocks, and you know from the metadata, based on how you want to restore, you get to the point and say, he needs a SharePoint restore, versus the same thing might actually be part of a file. But this is all a unique data set. So it's a fairly complicated file system, and this is where a lot of the file system experience comes into the team. As you can imagine, the toughest challenge here has been garbage collection. Because you got this SLA, which says, I'm a file, I'm supposed to stay for 4 hours. But part of that file happens to be something that came out of an Exchange server that's supposed to stay for 6 months. And here is an SLA that says, I'm expired, and somebody else comes back and says, well, I haven't expired. And you're trying to constantly do garbage collection. So the toughest part in this entire process, the rest of the layout process is fairly straightforward. It is the challenge, engineering challenges come in terms of how do you do garbage collection, how do you still be very, very efficient in how you go back and take care of placing, removing, and expiration of data without losing any data. So this is a fairly sophisticated process. I think we'll talk about, we filed about 16 patents around this whole area. And it's turned into a pretty, I would say, challenging engineering project for a very senior team. Any questions, thoughts?
Can you tell us whether the metadata is file-based or block-based?
It is an object-based.
Okay.
Because the metadata itself has information about things like this object belongs to X kind of applications. It is part of a file. It's part of a SharePoint. It could be part of Exchange, special version numbers. So I know how to, when you do recovery, you can make sure you tie it back to that format. So all you see. Well, there is a file system in that sense that it's a file, but the format of it is more an object based. And you can imagine this is what somebody was calling CDMI yesterday. The portability of this entire thing. So. April 2009, I believe, was when CDMI was put together. And one of our goals, and I saw the NetApp guys talk about CDMI for their reasons to try to make it an object-based system that could be independent of namespace and so on and so forth. Those are all the advantages. But the way we saw it fundamentally, and that's why we call it CDMI, was it allows you to really do data management independent of infrastructure, independent of whether it's somebody's cloud, somebody's on-premises storage. And this whole process of moving around, and there's a lot, I can go back into details of how data is moved very efficiently, doing the global deduplication across the network. How do you cut down the bandwidth of the network by 70% by knowing that there's already data on the other side before you even send it out on the wire? So there's a ton of stuff around just this file system that becomes the IP, core IP for us. Being pragmatic, since we're running a business and not a lab, we had to convert it back into something that is digestible by the users. This is a company that is very, very customer focused. If there's one thing that you will see as the number one goal for the company, it is being user focused. For 18 months, we've been working with 43 customers just in the Boston area, focused, flying nowhere and saying, let's make this thing work. And a bunch of resellers and customers helped us package the first of the 3 solutions that we announced. And they were tied to how people consume this part of the space. One, people want something for local data protection. You want to make sure that I can restore data, I want to protect it on premises, and I buy typically a snapshot tool, a backup tool, some deduplication tool, and maybe some compression tool. You have a single piece of software, starts on a pair of appliances that scales out to 8, supports up to 8 petabytes. That helps you do that. It's the exact same software, runs on the other side to provide you disaster recovery. Basically, it's the same thing, plus the ability to move data either to a remote site, or there's a virtual appliance that helps you get into a cloud. So this whole cloud, I mean, there's companies built around cloud gateway, the companies built around data domain. We try to come back and not talk much about the technology, because I think we saw this more as a focus on solution. But there's literally companies built around a couple of things that we're doing independently. And the last one is where you have multiple data centers running active. You're trying to run something like VMware SRM, Site Recovery Manager, or any other failover kind of software where you have data going on both sides. But notice, I have no disks. None of these things actually have disks. It's up to you to figure out as a user what disks you want to put and how you want to go back. It's purely a software-only play.
If you're acting as a gateway for sites using SRM, does that mean that you have to integrate with the SRM API?
We do. We have an SRA that works with this entire system. In fact, I'll tell you some use cases and why this has become one of the most compelling solutions for VMware SRM. Again, still localized towards the Northeast so far. Now let me talk about a little about how it really fits in. So here's your wonderful server, your application, your virtual servers, all kinds of storage that you have. We bring in a pair of our appliances. Right now it's all physical. There's a virtual appliance coming on the way. But what we do is we logically insert. Now this is where you got to figure out. We logically insert ourselves in the network. Sometimes it can be in-band. Sometimes it can be out-of-band. And again, when the cameras go off, I'll tell you about why this in-band has been trusted now. This is an in-band technology that's been used by 7,000 customers. Those in UK know it very well. About 15,000 installations. We licensed that core IP from another large company. Partly, in fact, primarily for one single reason, for trust. Could we have built this? Yeah. We're supposed to be, storage, bunch of storage jocks here. But trust was an important part. Interoperability was an important part. So it's all very pragmatic in how we put some stuff together. But what's happening is now, logically, the data is literally, we're always capturing parts of the data that's constantly going through. And now what happens is you come back and allocate some resources, create logical pools. Now you say, I want some pools for keeping data in native format, in capacity optimized format, some on the remote side. You start with, whatever. You walk into the vendor whose Q4 is going on right now and say, give me a great deal, I'll make your Q4 right now. And you buy the best storage you can find. Or maybe you use the one that you were phasing out that is coming off the lease. Then you go back and use our tool to set SLAs for the various applications. So you're starting to now, what you're doing is you're classifying your entire organization into well-defined SLAs for data management. You almost got down to saying, every one of my, as a chief data management officer, I know precisely, here's my gold class applications, my silver, my bronze class. But you start assigning those SLAs. And when I show you the demo, it'll show how simple it is. Once that starts, we start capturing. We look at the lowest frequency or smallest frequency or highest frequency RPO, start capturing only the delta changes. This is where the optimization begins. We start optimizing the workflow around what data needs to be captured, what can be reused. And then any change, this is the best part. Getting a product up and running is great. Supporting changes and making it dead easy when operational stuff changes, I think that has always been a challenge for any product company. I mean, it's very easy to get a disk array running until you have to reconfigure it. This is the part that makes it very compelling, where we completely change how easy it is to go back and change an application from being test and dev to production, from enterprise critical to enterprise support. Rather than call 15 guys and try to figure out how this logistics works, it's a simple SLA change. And I'll show you again what that is. The most important part here from an operational CapEx and OpEx perspective is you've got one place that you can completely optimize both the capacity and the actual network bandwidth usage, both locally and remote if you want. And the best part, again, like we said, is the fact that we don't sell storage. We're not packaging innovation in a box. It's innovation in software. Again, back to very similar theme of a hypervisor and a bunch of applications. And love your HP server, love your Dell server, love your IBM server. It's the same story on the data management side. We're applying the exact same philosophies in terms of having a hypervisor and a bunch of applications that are operational. completely independent of the kind of storage you have. Typically, at this point, the most common comment we hear from people is this. In fact, 2011, we have a too good to be true campaign. Basically says, if we don't prove to you that this thing's worked as we said it does, here's an incentive. And then, after they hear all this stuff, they ask us about this one. Right. And I'm.
Do you think they do? Not so much.
So I don't know what the answer should be, but I'll leave it to you guys.